Hello learners, in this lecture we will study Karl Pearson's method of coefficient of correlation and Spearman's rank correlation. The British biometrician Professor Karl Pearson has devised several formulae of algebraic nature for measuring not only the nature of correlation but also the exact extent of the correlation in numerical forms. For this, he represents the coefficient of correlation through the letter R and asserts that the value of his R must be in between plus minus 1. Coefficient of correlation under the direct method based on values where the size of the given values of the variables x and y are small, or all the values of variables can be reduced to small size by change of their scale or origin, stands as under r equals to given on the slide, where r is the Pearson's coefficient of correlation, x is the given or reduced values of the first variable, y is the given or reduced values of second variable, n is the number of pairs of observations. Under this method, the coefficient of correlation is defined as the ratio of covariance between the two variables to the product of their standard deviation. The formula is given as under. When deviation is taken from assumed mean, the formula for correlation coefficient is given as Spearman's correlation. Charles Edward Spearman, FRS, was an English psychologist known for work in statistics as a pioneer of factor analysis and for the Spearman's rank correlation coefficient. This method is a development over Karl Pearson's method of correlation on the point that first, it does not need the quantitative expression of the data. Second, it does not assume that the population under study is normally distributed. Under this method, correlation is measured on the basis of the ranks rather than the original values of the variables. For this, the values of the two variables are first converted into ranks in a particular order. Spearman devised the formula as R equals to 1 minus 6 summation of d square upon n cube minus n equals to 1 minus 6 summation d square upon n square minus 1, where d is the difference between the pair of ranks of the same individual, n is the number of pairs, and r is the coefficient of correlation. When two individuals are given the same rank, when there is more than one item, the value rank in either or both the series and average rank is given to all the equal items. In case of equal ranks, an adjustment is made to the above formula by adding 1 by 12 m cube minus m to the value of summation d square as r equals to 1 minus 6 summation d square plus 1 by 12 m1 square minus m1 plus 1 by 12 m2 square minus m2 plus, and it's go on upon n by n square minus 1, where m is the number of items whose ranks are equal. So, in this lecture, we have covered Karl Pearson's method of coefficient of correlation and Spearman's rank correlation. See you in the next lecture. Thank you.